Good day, dear viewers. You're watching the Number Sense channel. In this first video, we'll explore the topic of the coordinate plane and the linear function. To begin, let's examine how the equation of a straight line is written. First, we need to define the term m in the function. As written in textbooks, the gradient of a line is defined as the change in the y-axis with respect to the change in the x-axis for that line, or simply, the slope. While this may not sound very convincing or clear at first, we'll see its application visually on a graph. Next, we'll look at the coefficient c. According to textbooks, c is described as the intercept point of the function on the y-axis. This also sounds intriguing. Finally, we have the coefficients x and y, which many of you might already be familiar with. Y corresponds to the ordinate and x to the abscissa. Not too complicated, right? Let's break down the simplest linear function by assigning specific values to m and c. Let m equal 1 and c equal 0, leaving us with the function y equals x. Let's visualize this function. On the graph, we can see that this line passes through the origin, the point where both the x and y axes are 0. Now, let's incorporate the coefficient m and observe how the function changes visually. We'll start with a small value for m, say 0.01, and gradually increase it to 100. When m equals 0.01, the angle between the function and the x-axis is approximately 0.57 degrees. As we increase m, it becomes evident how the slope of the function steepens. The angle reaches 45 degrees when m equals 1. Fascinating, isn't it? This shows that as m increases, the angle between the function and the x-axis also increases. If m were to approach infinity, the angle would approach 90 degrees but never quite reach it. Let's move on. Now, we'll discuss the 4 quadrants of the coordinate plane. They are numbered in a counterclockwise order, starting from the top right quadrant. We've analyzed values of m ranging from 0 to 100. Next, let's explore what happens when m takes on negative values. As we decrease m, we find that when m equals -1, the line slopes in the opposite direction, forming a -45-degree angle with the x-axis. As we continue to decrease m, the angle approaches -90 degrees. From this, we can conclude, as m decreases to -infinity, the angle of the line approaches -90 degrees. Now, let's consider the effect of c and determine which quadrants the function occupies at various values of c. When m is negative, the function lies in the second and fourth quadrants, highlighted in yellow. Conversely, when m is positive, the function is in the first and third quadrants. Here's an interesting question. Can a linear function pass through 3 quadrants at the same time? Or can it only occupy 1? Let's find out with the help of the coefficient c. Starting with the function y equals x plus 0, We'll gradually increase c to 5, then decrease it to -5. What happens if we also adjust m to 10, or decrease it to -10? And what if m equals 0, while c equals -5? Each scenario provides a compelling visual demonstration. When we set c to -3, we observe the line passing through the first, third, and fourth quadrants simultaneously. Similarly, when c is increased to +3, the line spans the first, second, and third quadrants. From this, we conclude that a linear function can occupy 3 quadrants simultaneously, but never just one, regardless of the values of m and c. Let's tackle a problem now. Pause the video and try solving it yourself before continuing. To begin, plot 2 points on the graph. Our task is to find a function that connects these points. First, we'll use the formula for m. Substituting the values, we find that m equals 4/3. Next, let's determine the coefficient c by substituting one of the given points into the function. This leaves us with a single unknown, which we solve to find c. With both m and c calculated, our function becomes y equals 4/3 x plus 1/3. We can see that this function passes through both points. Congratulations! We've solved the problem correctly. If you enjoyed this video, don't forget to like and subscribe to my YouTube channel. See you next time.